The reactivity series is a ranking of metals based on their ability to react with other substances, particularly acids, water, and oxygen. It is a crucial concept in chemistry because it helps predict how different metals will behave in various chemical reactions. The position of a metal in the reactivity series is determined by its tendency to lose electrons and form positive ions, cations. Metals that lose electrons more readily are more reactive and are placed higher in the series, while less reactive metals are found lower down. The reactivity of a metal is essentially a measure of how vigorously it can undergo chemical reactions, particularly oxidation reactions where the metal loses electrons. For example, highly reactive metals like potassium, sodium, and calcium are found at the top of the reactivity series. These metals react explosively with water and acids, quickly losing electrons to form positive ions. In contrast, metals like gold, platinum, and silver, which are located at the bottom of the reactivity series, are much less reactive. They resist oxidation and do not react easily with acids or water, which is why they are often found in their pure form in nature. One of the key ways to determine a metal's position in the reactivity series is by observing its reaction with acids. When a metal reacts with an acid, it typically displaces hydrogen from the acid, forming a salt and releasing hydrogen gas. The speed and intensity of this reaction can indicate the metal's reactivity. For instance, when a reactive metal like magnesium is added to hydrochloric acid, it reacts vigorously, producing bubbles of hydrogen gas and forming magnesium chloride. In contrast, a less reactive metal like copper does not react with hydrochloric acid under normal conditions, indicating its lower position in the reactivity series. This lack of reaction shows that copper is less willing to lose electrons and form ions compared to magnesium. Metals also react with water, and these reactions provide further insight into their reactivity. Highly reactive metals like potassium and sodium react violently with cold water, producing hydrogen gas and a metal hydroxide. For example, when sodium reacts with water, the reaction is so vigorous that the sodium often catches fire. Less reactive metals, such as iron, react more slowly with water, usually only reacting with steam rather than cold water to produce a metal oxide and hydrogen gas. Metals like gold and silver, which are at the bottom of the reactivity series, do not react with water at all, even at high temperatures. The reactivity series not only helps predict the outcomes of reactions but also plays a significant role in industrial processes such as metal extraction. For instance, metals higher in the reactivity series, such as aluminum, are extracted from their ores using more energy-intensive methods like electrolysis, while less reactive metals like iron can be extracted through simpler reduction reactions with carbon. Understanding the reactivity series is crucial for predicting how metals will behave in different environments, their potential applications, and the methods needed to extract and refine them. The position of a metal in the reactivity series determines its reactivity with acids and water, guiding chemists in choosing the appropriate reactions for practical uses and industrial processes.